Hello everyone. So I was looking at assigning your homework and I found this problem that I stumbled across that I realized we didn't talk about in the notes and I wanted to talk about it really quickly. So here we have an equation. It's an equation because I've got an equal sign, I've got plenty of variables, so it's actually a variable equation. And the claim in this problem is that all of this is a circle. Now, this seems very odd because what we're used to thinking of as a circle would be something that has parentheses and squares, and it would look like that Pythagorean theorem. But this doesn't look at all like the Pythagorean theorem. And I'm going to show you how we can connect those two dots. So here we have, I've copied down the exact same equation. We've got this x squared plus y squared minus 6x minus 12y plus 44 equals 0. Now keep in mind that the standard form of a circle that we're used to seeing is something along the lines of like an x minus h, let me put that in, x minus h squared plus y minus k squared equals r squared, where all of this kind of resembles that this is one leg of my triangle, like an a squared, and this is another leg of the triangle, like a b squared, and this is the hypotenuse of the triangle, like a c squared. And really, we're leaving things as variables so we can talk about any type of value that gets me my legs of my triangle, or my height of my triangle, or my radius being the only thing that's maintaining a constant value. So it's every triangle with a hypotenuse value of r would get me a circle with radius r. But this doesn't look anything like that. But that's okay. As mathematicians, we're going to take a moment and we're gonna step back from this and we're going to see what parallels we can find. First, we could confirm that if we actually threw this into a graphing calculator, that it actually does get us a circle. So that'd be a nice first step. So here I am at GeoGebra. Okay, so we do see that this does turn out to be a little circle here, right? It's my circle of f, and it's got a little circle here. And notice that even in GeoGebra, it actually solved this for me. I've got x minus 3 squared plus y minus 6 squared equals 1. That's what it's claiming is my circle. That's very odd. I'd like to find out why that is. So let's go back over and see, is it true that this is a circle? Is it true that it's a circle of what looks like radius 1 that's centered at 3 and 6? Let's play around. So now let's go back over here to our math and see what we can do to make this entire equation look like this equation over here to the right. So what can we do? Well, the first thing is I noticed that these are squares. These are numbers that are squared. These are binomials being squared. And I've played around with those back when we were playing with polynomials. Okay. And normally, if I remember trying to take something that was x squares and my x's, I could make that into a square so long as I completed it, so long as I completed my square. Oh, isn't that interesting? Let's take a moment here and do a little bit of side work. We'll say that I have an x squared and I have a minus 6x, and if I could complete this square, then I could rewrite it as a square. Okay, what would that square look like? A perfect square would be x squared in the top left. I would put half of my negative 6x's up here. That'd be negative 3x's. I put another negative 3x's down here. In my picture, that would be dimensions of x and minus 3 and x and minus 3, so that would make this have to be a 9. Okay, so I'm missing a plus 9. I need a plus 9 here. If I could put in a plus 9, then I'd be able to complete my square. Okay, so I'm missing a plus 9. What about the y squared? Let's see. From the top, I've got, let's see if I was to highlight them, I've got a negative 12y, and I've got a y squared. So we could write that down here, y squared minus 12y. And I need to find some way to complete that square. So that would be, let's see, y squared would be in my picture. Negative 6 of those negative 12s would need to go up here. Negative 6 of those negative 12s would need to go down here in my picture to maintain my symmetry. And that would give me dimensions of y and minus 6 and y and minus 6, which would make my bottom right corner be positive 36. Oh, so that's what I'm missing. I'm missing 36 right here. Okay, so if I had 9 and I had 36, I would be able to write all of this using perfect squares. So let's kind of put that in. I'm going to say I have x squared, I have the minus 6x from above. I'm going to introduce a plus 9 on the left-hand side, no problem. Let's see, I then have my y squared from the original problem. I have a negative 12y from the original problem, and I wanted to introduce 36. Okay, no problem. I have my original 44 from the problem, and I need to make sure that I keep this whole thing balanced. So we're going to add 9 and add 36 to the right-hand side. I could simplify all this up and take advantage of all my work because, again, I've now given myself everything I need to write this as a perfect square. So this could be x minus 3 squared, because again, this was a square that I made from x and minus 3. So here we are, x minus 3 squared plus all of this. This is my y minus 6 square. So I can put that in, y minus 6 square plus 44 equals, it looks like 45? 45. Very nice. I can simplify that up a little bit more because the standard form of my equation has all of my numbers on the right-hand side that aren't in parentheses. So that'd be x minus 3 squared plus y minus 6 squared. I would need to take away 44 from the left to get rid of that, and I'd take away 44 from the right to balance this out. So all in all, I think that would leave me with equals 1. Oh, look at that. This is exactly what we were playing with back when we looked in GeoGebra. It's a circle whose center is 3, 6, right? Because I'm looking at the numbers here. X minus h would be my h value of 3, and y minus k, my k value is 6, so my center of h comma k would be 3, 6, and then my radius would be the square root of 1, which is just 1. And there we have it, a circle. And I could sketch it out the same as we had on GeoGebra. It was 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, 6, a center here at 3, 6, with a radius of 1. Nice little circle right there. Kind of interesting that even in all this hodgepodge, if we go back to our idea of completing the squares and we're able to get things in terms of squares, that really what we're doing is we're taking a massive of numbers, a massive variables, a huge polynomial expression. We're taking a polynomial expression, writing that in terms of squares, using our squares to talk about things in terms of triangles, because the Pythagorean theorem talks about connecting squares and triangles. And then once I've got it in terms of triangles, I'm able to represent it as a circle. So I've gone from a pile of things to squares to triangles to circles, and really shown that all along the way it was nothing different than anything else. Hidden in this circle is all the information in squares, rectangles, and numbers, so that if I combine them in just the right way, I transform the meaning, the simplest expression of this, to being that of a circle. Kind of crazy.